What's up, everybody, and welcome to OFHS Monday Night Football. What's that? There's no sports going on right now? All right. Welcome back, everybody, to OFHS Monday Night Polynomials. What's up? Where we got a battle between the Olmsted Falls Bulldogs and Mr. Z's math problems.
What is up, everybody? Today, in Algebra 2, we're going to learn about some polynomials. And I'm going to get to that vocab in a second, but I'm first just going to start you with some things that you may have done before, may have seen before, and everything's going to focus on graphs today. So I'm at desmos.com/calculator, or just desmos.com. I'm going to start to type in a few equations that you have seen before, like y equals x plus 1. This is a line. We know that's a line. It's also called a polynomial. A polynomial is like the bigger umbrella, and then a line is like the more specific thing. Like we are all humans, and then we might be like football fans or Frisbee fans, or we might also be students or teenagers or things like that. We can be more specific with our gender, and so forth. So overall, this graph is called a polynomial. Specifically, it's a line, but we're just going to talk about polynomials. Think about the word poly. You might know some other words like monopoly or polyamorous or things like that. Polychromatic, I think, is one. Poly means many. So polychromatic means many colors. Polyamorous means you can have many loves or many types of love. Monopoly is somebody who owns many companies or many things. So a polynomial has many numbers or many names or many parts to it. So right here we have an x number or name. We have a 1 as a number or a name. So a polynomial just has many parts or names or numbers to it. When we learned how to graph this in Algebra 1, we probably start with the y-intercept right here. But we're going to start to notice something different when I put more parts to this polynomial, when I put more parts to it. So I'm going to go ahead and add an x plus 2. This is still a polynomial. Has many parts, many numbers to it. Desmos does a nice job of highlighting some key points down here, not only the y-intercept anymore, but also some x-intercepts and some other key points. So this graph is also called a polynomial. And now I'm going to go ahead and add in an x minus 3 as a next part, and maybe things are starting to blow our mind a little bit. So we still have many parts, many numbers, many variables in this problem here. And now the y-intercept doesn't seem to be as important. -6 we don't really see in the equation, but what we do see is that -2 is a key point. -1 is a key point. And 3 is a key point. Think about how these fit into this equation. Like if you plug in 3 into the equation, what do you get? Well, there's a quick, easy way to do this. I change this from y equals. Instead, I call it f of x. It's the same graph. What happens when you plug in 3? F of 3 is 0. F of 3 is 0. What happens when I do f of -1? It's 0. F of -1 is 0. Let me just try f of, I don't know, 2. F of 2. Oh, that's -12. That's way down. It's a point that's further down off my graph here. But what these key points are telling me, like f of 3, is it's telling me where it's going to hit 0. So we know these as x-intercepts. Another phrase for these is called the zeros. So these are your x-intercepts, or they are your zeros. There's another word. These are also your roots. So I'm going to go ahead and just write that these are x-intercepts. Whoa, that's kind of weird. That's okay. X-intercepts. There we go. Or these are our zeros, or these are our roots. There's probably a better way to do that. I'll figure it out. But now that we know, we have a couple of vocabs for what these are called here. So if you notice there's 3 x's, 3 parentheses in this problem, there are 3 roots to this problem, right? If I delete one of these and there's 2 x's, you're going to see that there are 2 roots in the problem. There's also like 2 parts to the graph, like it goes down and then it goes up, right? Or this one, there's 3 x's. Not only are there 3 x-intercepts or 3 roots or 3 zeros, there's also 3 parts. There's this part going up like a roller coaster, down like a roller coaster, and then back up. There's kind of like 3 parts to that. So a little bit of vocab for us. Polynomials is the big umbrella idea, but you can have a line. That is a first degree polynomial, meaning there's 1 0, there's 1 x in it. Quadratic, we know that as a parabola, that's a second degree. There are 2 zeros, there's 2 x's. A cubic, we've worked with things to the 3rd power before. That is a 3rd degree or a 3rd power. There's 3 zeros, we're going to see 3 x's. If I did multiply this problem out right here, that'd give me y equals x to the 3rd, and then some other stuff after that. And then we haven't learned this yet, but a quartic would be a 4th degree and a 4th zero. You know that polynomials can look very different, right? 1x, 2 x's, 3 x's, or it could be x to the 3rd, and so forth. So we've got a graph here where we learned zeros, x-intercepts, and roots. We learned it as both y equals and as f of x equals. Those are the same thing. I could change it to y equals. Notice the graph didn't change, right? If I change it to f of x equals, the graph didn't change. Go back to y equals, it's the same graph. So we learned a little bit about some roots, zeros, and x-intercepts. Also, if there are 3 roots, that's a 3rd degree. It's going up and then down and then up, like 3 hills. I could add a 4th one in here, x minus, I'm gonna throw in a decimal just for fun, 0.1. We can see that there's 4 x's, 1, 2, 3, 4 parts, 4 hills, 1, 2, 3, and 4 x-intercepts, 4 roots, 4 zeros. So we can see that that connects directly to these. X plus 1, how do you get to 0? -1. X plus 2, how do you get to 0? -2, there it is. X minus 3, how do you get to 0? 3, 3 is the 0. And x minus 0.1, there's 0.1 as our last 0. So hopefully that helped us out a little bit with figuring out what a polynomial is, how many roots or zeros or x-intercepts that it has. I'm going to go ahead and switch things up a little bit here. Oh, by the way, I did something a little bit different in the settings to be able to count by 1. I hit the wrench, the settings gear, and I changed the step to 1. This might be how it looks without that. If you didn't, if you just showed up to Desmos to start, actually, let's just go to Desmos to start. I'll reload it, and it looks like this. There are little marks here, but it's not counting by 1. That would be a half, 1, 1.5, 2. So I like going to the settings and changing the step to go by 1. And then you might see there's still some little minor lines in here. Go back to the settings. In minor grid lines, I click off of those. So now I just have counting by 1s, right? So little second equation, second problem, let's start with x plus 2. So again, there's 1x. It is a first degree polynomial. We call that a line. I'm going to go ahead and add a second x. And we have a second degree or an x squared polynomial. And there are 2 x's, 2 zeros, 2 x-intercepts, 2 zeros, also 2 roots, just another vocab. I'm going to try something a little bit different here. And I'm going to put in another x plus 3 and see what happens. All right, I'm going to zoom in on this one a little bit. So we've got x-intercept at -2, which we might have assumed right here. X plus 2, how do you get to 0? That would be -2. -2 does indeed get you to 0. X plus 3, we would need a -3 to be 0, but it doesn't seem like we have another root. This is a 3rd root, 3 x-intercepts. Well, what's interesting is this -3, since it happened twice here, this is called a double root. So instead of passing through the point like this does, it actually bounces off and makes a little parabola right at that point. So that's called a double root, double root that we have there. So at -3, we have a double root. This is the same thing that if I did x plus 3 twice, like I might see x plus 3 squared. That's the same graph there. So I could put it twice like that, or some people like to see the whole root written out, x plus 3, there it is, the same exact thing. So this right here creates a double root, or if we had it with an exponent squared there, this is a double root where it bounces off of the line. All right, so let me go back and pick a different number, x plus 4. And zoom back to our home, we can see there's 3 roots, 3 x-intercepts, 3 zeros. See those 3 zeros right there? But if I went ahead and added a squared to one of these, we would see that it bounces off of the -4, right? Again, I'll zoom in a little bit. We can see that it bounces off the -4. The -3 crosses through the -3. It crosses through the -2. But at this -4, it's a double root. The double root doesn't have to happen at the end. It can happen up here at the beginning. And now the double root is going to bounce off of the 0 of -2. So question for you, there's 3 zeros. Is this a third degree? Is this a what they call a cubic? If I go back to my little chart here. Third degree, 3 zeros. Is this a cubic or is it a quartic because there are 4 chunks here? Like what if there's another x plus 2? What if there's another x plus 2? This is the same graph there. There's 4 x's, that should be a quartic, right? Follow along the roller coaster ride here. 1 going down, 2 goes up, 3, the hill goes down, 4, the hill goes up. This is a 4th degree polynomial. There should be 4 zeros. There are 4 zeros. This 0 right here just happens twice. It is called a double root. So we got to look for that bounce to happen for that to be a double root. So hopefully you learned something about polynomials today. We're going to learn some more in the next lesson. But really the key thing is that we can make equations no problem to match the zeros in the x-intercepts and the roots just simply by using these parentheses. This is called factored form. So when I have it factored into all the x's, it's not the x to the 4th problem, it's factored, so I can see all of the x-intercepts. I can see all the zeros. I can see all the roots right from here. I don't even need the graph. I know that -2 is going to take me to 0. I know that -2 is going to take me to 0. I know that -3 is going to take me to 0. I know that -4 is going to take me to 0. So we learned about polynomials. We learned that there's many kinds of polynomials, but we should pay attention to what degree it is or how many zeros there are. We can count those by counting the hills going up and down to figure out what degree it is or how many zeros there are. Or we can check how many times did it hit the x-intercept, right? Was there 1 root or 1 zero, 2 roots or 2 zeros? But we do got to watch out if there are any double roots, if it bounces off of that x-intercept. And we'll go ahead and finish up by going back to a basic problem that you may have seen early on in your math career. I'll just delete everything. Y equals x plus 2 and then squared. You would suspect that would be a parabola, and it absolutely is. It's a quadratic, and it hits at -2, which -2 does indeed give us 0. And look, here's that bounce. It's bouncing off of the x-axis. It is a double root. We can see there's a hill down and there's a hill up. That's a double root. What happens if I add an x plus 3? It turns into 3 parts. There's an uphill. There's a little downhill right here. And there's another uphill. That is a 3rd degree. There are 3 x's here. If we look at the equation, that's x plus 2, and then x plus 3. That is 3 factors, 3 x's, 3rd degree. What do you think about this one? Put another squared. This is x plus 2, x plus 2, x plus 3, x plus 3. I'll go ahead and write it out for you and show you it's the same exact thing. X plus 2, x plus 2, x plus 3, and x plus 3. And we can see that the green overlapped with the red there. It's a little hard to see. Are there 4 degrees? Are there 4 x's here? If I zoom in, we can see that there is a down part. There's an up part. There's a down part. And there's another up part. There is a 4th degree. Sometimes that's not so easy to see just by counting the zeros. So don't rely on the zeros the whole time. Don't rely on the x-intercepts. That's why we have Algebra 2. It's a new lesson. Otherwise, you'd be back in freshman algebra, right? So don't just always look at your x-intercepts. Look at the hills on the graph, or look at the equation. The equation is going to tell you there's 4 x's. It's a 4th degree. We should be looking for 4 zeros. -3 is a 0. It's a double root. So it's -3 and it's another -3. -2 is a double root. So it's a -2 and another -2. So we do have 4 roots because it's a 4th degree, because we got 4 x's, because we got 4 hills, down, up, down, up. So we do have our 4 roots. If you see it like this, which you often will in a math textbook, just know that this x is squared, that's 2, double root. And then this x over here is squared, that's another double root. That makes it 4 roots, 4 zeros, 4th degree polynomial. Thanks for joining today, and let me know if you have any questions.